Hey, everybody, this is Alex Merced from alexmercedcoder.com with another video on programming in the Dart programming language. And here we're going to talk about, first I'm going to introduce arrays real quick. Arrays are just ways to have sequences of data in one nice tidy place. Generally, most languages, pretty much every language has arrays, and arrays get treated, also generally have a bunch of cool methods that you can use in any programming language. So after learning arrays, you should definitely go out there and take a look at, for array methods in Dart. That's generally some of your most fun tools. But all an array is a variable. So let's say here, var, we'll say my array equals, an array is usually always symbolized by a square bracket. So in this case, we'll say 1, 2, 3. There's my array. Okay. And now I have 3 numbers in there, 1, 2, and 3. And the way it works is that now I want to print the value of my array. So let's first print the whole array. And then let me copy and paste that 3 times. Because the way an array works is that it's indexed, meaning if I wanted to get just the 1, I need the first index, which is always 0. So my array 0 would be the first value. Then my array 1 is the second value. My array 2 is the third value. Cool. So say it prints out the whole array and then 1, 2, 3. So that's fun. But where arrays become useful is that you can iterate over them. So for example, using that whole loop structure, I could do something like this. So using for var I equals 0, as long as I is less than, there's usually a function to find your array length. So it's probably my array.length. But to keep it simple for today, I know that the array is 3 items, so we'll say less than 3 because you want it to be 0, 1, 2. Okay. And then at the end of each loop, we'll increment. Okay. And then each time the loop goes through, we're going to print my array. We're going to print my array of index I. Okay. And then we'll close the loop. That's literally all the loop will do. And then we run. And see it prints out 1, 2, 3. Why? Because the first time I is 0, so it prints out my array index 0. Then it loops again, it's I is 1, then I is 2, so it prints out all the elements of an array. So if you need to do something to a bunch of elements, having it in an array allows you to iterate, or basically I can then do something like this, print array plus 5. And that'll print each number with 5 added onto it. Okay, so that's pretty cool. You can do some pretty cool stuff with that. So that's an array and sort of iterating over an array. And iterating means looping over it, going through the different contents. Now, one of the main things what's called object-oriented programming. So object-oriented programming is the idea that everything is an object. So like a dog is an object. And whenever something is an object, you need to describe it. Instead of just saying, okay, creating a program that describes things that are happening, you're going to create a thing first and describe what it looks like, how it behaves, and then basically with those, anything that describes something, it's called a property. So these are variables. Anytime the thing does something, so the verbs. So one way to think about it is the variables in an object, the properties are the adjectives. That's how I would describe the height of a dog, the color of its fur. While the things that a dog does, like barks, these are going to be functions. These are verbs. So functions are always verbs. Okay, and then the class itself is the noun. Okay, so every noun has certain adjectives and is able to do certain verbs, and that's essentially what we're doing with object-oriented programming when you think of it from a linguistic sense. Okay, so the way you create a new type of object is called a class. So before we can actually have a dog, I need to describe what dogs are. So the idea of a dog is called a class. And once I have that class, that idea of a dog, I can then actually create dogs, which are instances of the object. Okay, so for example, we're going to create a new class called dog. And that's all you do. Okay, basic class dog. And then inside these curly brackets, I can describe any functions a dog has, any properties a dog has, etc. So I can be like, the dog has, a variable with an integer, that is its age. Okay. It has a string variable, that is its name. It has a I will leave it at that. We'll keep it simple. And the dog also has a function. I'm going to use the word void. The word void just generally when you put a type before the name of a function, it means that that function is going to return that type of value. So I'm just going to say that void always means it doesn't return a value. So void bark takes no parameters. And in this function, all that's going on is we're going to print bow wow. Okay. So right now we have the very, very basic class. So technically now I can create a new dog. So I can be like, and the way that works is I would go back into my main function where I do stuff to get rid of the array. So I'm going to say, I'm going to create a new dog named Sparky. And basically what I'm really saying is I'm creating a new variable of the type dog. So this variable is a dog object, and it's going to equal a new dog. So it doesn't equal an existing dog, because you can do that. You can sit there and say, hey, this Sparky dog I made already, I'm going to make a copy of him. But no, I'm creating a whole new fresh dog, and that new dog, oh, that's it, because I didn't give any we didn't make any constructors yet. I'll get back into that in a second. So dog Sparky equals new dog, and then I can just say, hey, Sparky, I want Sparky to use its function, which is bark. Okay, so Sparky barks, and if I run that, type string not found. That's interesting. I spell string wrong. We'll come back to that. Okay, we'll just keep it at that. Name, expected for this. And that was basically on 21. Let's put 21. Take a look. Sparky. Oh, still wants me to put parentheses over here because yeah, technically it's calling a constructor function even then, even if there isn't one. So we'll leave it at that. So run. And there you go. So see, basically here, I created a new instance of the class dog, which I describe over here, and it knows that since Sparky is a dog, it can use this function called bark that's in the dog class. And I can create as many dogs as I want. I can create a variable pound. But Sparky doesn't have an age, okay? So because it never asked me for one. So this is where we create a constructor. Okay, a constructor is just a function that generally has the same name of the class. Okay, so this would essentially be dog. And then we'll say takes a parameter of int a. So this is going to put int ag, so for age. And then some curly brackets. Okay, and we're going to say that. And generally, whenever you're talking about this version of the dog's something, you refer it to as this. So this means because the dog doesn't exist yet. But when I'm saying this dog, it means this instance of dog. So this dot dog's age, because we already declared the variable age. So this dot age is going to equal the parameter that we gave through in there as ag. So all this is what's called a constructor. I'll never call this function. I'll never sit there and actually type in dog.dog. The way this works is that since it has the same name as the class, when you actually instantiate the class, when I create Sparky, it's going to run this function. Okay, int.dog, so now I have to give Sparky an age. So we'll say he's an older dog. He's 10 years old. Okay, now I run that. Wow, that doesn't really change anything. Let's print it. We should probably print the variable so we know that we actually assigned it. So print Sparky's dot age. That's how we can access the variable. Sparky.age. Okay, so within the function, this represents Sparky, the Sparky that we have not yet created. So that's why I'm saying this.age. You can think of it as Sparky.age equals parameter. Okay, so print Sparky.age. Let's see, let's run that. Make sure that all runs fine. And there we go. So bow wow 10. Because when I created the new dog here, I passed in the value of 10, it called on the constructor function over here and said, hey, we have this parameter, you gave us 10, so this dog's age, Sparky's age, is now 10. And then that's how that works. Now here's where it gets cool. Now generally in most languages you're allowed to override the constructor. So I can make different versions of that constructor with 2 parameters, 3 parameters. As long as it's a different number and type of parameters, you can create another version of the constructor for different situations. But what if I wanted to have 2 different parameters and different constructor, that still took 1 int. This is something that I have not seen in other languages where you can actually create multiple and you can create named constructors. So I can do something like this. Dog.old int ag. So same story. The only difference is that whatever age you give it, we're going to make this dog old. So this dot age equals ag plus 10. Okay, so we're going to age the dog a little bit. So if I were to change, so now when I call the construct new dog, I can be like dog.old. It'll call on that .old constructor when it constructs the new dog. Okay, and now it should give me an age of 20. So bow wow. Okay, so basically it called a different constructor because I explicitly told it to call the constructor with that type. So it still created a new dog with all the functions and all the other stuff that's in the class, but it called a different constructor function that did something else initially. So Sparky still barks, bow wow, and Sparky is just now, Sparky's really old. Added 10 to his age. So this gets more useful when you start thinking of like probably the easiest application is thinking like a video game. Like if you ever played like Dynasty Warriors, one of those video games, so there's sometimes like hundreds and hundreds of different like enemies that you're fighting with on the screen. Okay, that would be really annoying if some programmer out there had to program each one. No, they're objects. Okay, and then chances are when they get created, there's generally a couple different sort of basic molds of what those enemies are, and their constructor function basically sets up all the stats, sets up everything pretty much right away. So they're just creating new instances of these like sort of foot soldier type objects that, and basically that keeps track of their hit points, that keeps track of their strength, their defense, and all that stuff. And then every time they attack you, that they're invoking a function that's attack that's going to tell them, okay, well, we're going to use your strength value and figure out this much damage and do all this stuff to figure out whether you hit the person or not. This is where object-oriented programming starts really becoming really useful, especially with games where you literally do have objects that are constantly interacting with each other, particularly like video games. Although, I mean, even in more traditional programming applications, that objects are so important. For example, if you're creating let's say a file sharing type application where you're sharing files with people, every file that's being shared is an object that you're able to do certain things with. That has certain properties, like is it shareable, is it not shareable? Function like send, function receive. There's all sorts of different ways you can break it down to encapsulate the concept. It makes it easier for, and again, a lot of time what you're doing is you're programming libraries for other programmers. So you're describing how these things are going to work together. Then other programmers will take it to the next level to create the actual program's functioning. So, some people are like, well, I know what it's supposed to be like, so I can just do it this way. But you're oftentimes not programming alone. So what everyone's trying to do is create the pieces to the puzzle in the most intuitive way possible, so everyone can put it together and change it as they need to in the future with minimal complication. So this is essentially the core of the Dart programming language and the syntax and whatnot. So now that you kind of know these pieces, you can go out there, Google array methods, do some basic practice. Start learning some of the, now again, Dart has other stuff, so that way you can create mobile applications, so that way you can create web. So now that you have the core, you can go out there and start looking into those, like how do I put stuff on the screen to do stuff visually and make a web application or make a mobile application? How do I use Flutter? You can go into the next step now because you know the core, you know how the code works. But again, also, I highly recommend practicing it. So head over to codewars.com and start doing practice exercises. in Dart. And you're going to feel like a lot of times like, wow, man, I thought I learned so much, but I don't know how to attack this code problem. And that's honestly one of the best ways to learn. You do some sort of exercise, you realize that there's got to be a better way to do this than this really long way that I'm doing right now. So then you do some Googling, you learn some new methods, you learn some new functions, you learn some new tricks, and you get better and better and better at solving problems to the point where you get really comfortable with coding. So go out there and do that. My name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.